Hi, in this video we are going to make an experiment that will consist in 3 parts. First of all, we have an elastic fabric tightened and fixed to the walls of a solid cylinder. We are going to see that we can visualize the gravitatory potential that a body generates in space as the deformation that it generates in an elastic fabric when the fabric is holding the rigid element. Moreover, as you can see in the image, the value of the gravitatory potential can be seen as the distance between a point and the plane of the fabric when it's not holding any element. In the image, it would be the red arrow. In second place, we are going to see that when we submerge the fabric completely in water and introduce a floating body, in this case polystyrene, the exact same effect is produced but with the opposite sign. This is due to the fact that the floating force has the same direction but opposite way as the gravitatory force. The deformation of the fabric is upwards. Therefore, the deformation is opposite of the one produced by the gravitatory force. Now we are going to try that the deformation that both forces cause in the fabric cancel each other. To make this experiment easier, we are going to stabilize both bodies by fixing them to an axis. This axis won't allow the bodies to flip over each other, so now they will only move upwards or downwards. Also, we can see that given a certain floating body, we can add non-floating mass to the experiment up to the point to where both forces, the buoyant force and the gravitatory force, cancel each other. Finally, we are going to make an analogy between the positive and negative electric forces and the gravitatory force and the buoyant force. In this analogy, the non-floating body behaves as a positive charge and the floating body as a negative charge. Despite the electric potential can be represented this way, it works in the same way as the deformation we have seen. The negative electric potential works as the deformation of the floating body, and the positive electric potential works in the same way as the deformation of the non-floating body. Therefore, if we deform our non-floating body in our analogy at a distribution of the positive charge in a ring with the same center as the floating body, in our analogy the negative charge, the result is a null potential outside the ring. This way, we can visualize the result that the theory predicts. According to it, the electric potential of a point is proportional to the integral of the distribution of charges of the ring, plus the electric potential that the second charge produces in the point. If we calculate this integral, we find that at any given point outside the ring, no matter which direction, the potential at that point is 0. This result fits with the experiment's findings.